Okay, in this problem, we are doing another chain rule problem. So part A says, find the equation of the tangent line to the graph of f of x equals the square root of x squared plus 3 at the point -1, 2. And part B says, find the equation of the normal line to the graph of the same function at the same point. And part C says, where does the normal line from part B intersect the x-axis? So take a moment and try to figure out the answer yourself, and then we'll go over the answer. Okay, so part A, we have to find the equation of a tangent line. And we know that we just need to find the slope of the line and a point that is on the line. And the slope of the tangent line is given by the derivative at that point. So we're trying to find the tangent line to the graph of a function. We need to take the derivative of the function. So f of x is the square root of x squared plus 3. And we need to take the derivative. And for that, we need to use what? The chain rule, because we have a composition of functions. X squared plus 3 is the inside function, and the square root of x is the outside function. So what we need to do is we need to take the derivative of the outside function. So the derivative of the square root of x is 1 over 2 times the square root of x. But instead of plugging in x, we need to evaluate f prime at the inside function, which is x squared plus 3. So it's x squared plus 3. And then we have this, and then we need to multiply by the derivative of the inside. And the derivative of the inside is, what's the derivative of x squared plus 3? 2x. Right? And maybe I'll just write out, okay, this might be a little too much, but I'm writing out all the steps, and those that have parentheses. The derivative of x squared is 2x, the derivative of 3 is 0. But this is going to be 2x over 2 root x squared plus 3. Right? Because I have a product. So I have this fraction times this thing, and then that's the same as making the thing inside the numerator of the fraction, right? Because I have this over 1, and then when you multiply fractions, you multiply the numerator and denominator. And now I can simplify this a little bit, because what I have is 2x over 2 times the square root of x squared plus 3, and this is, I have this thing, and then I'm multiplying the numerator and the denominator by 2. And if you do that, you don't change the fraction. So this is going to equal x over the square root of x squared plus 3. Notice that I can cancel the 2's because I have a factor of 2 on the top and a factor of 2 on the bottom. That's really important. If you had 2 plus x on the top, then you can't cancel out the 2's, because if you had 2 plus x, that's not 2 times, you know. I can only cancel out the 2 like this if I have 2 times something. So I just wanted to emphasize that. Okay, so that's the derivative of f. And now what do we need to do? We need to find the slope of this tangent line at the point -1, 2. So the slope of that line is going to be f prime evaluated at -1. Was it -1? Yeah, -1. So we need to plug in -1 into the derivative, and that's going to be -1 over the square root of -1 in parentheses squared plus 3. And let's figure out what that is. That's -1 over the square root of -1 in parentheses squared is 1, and then I have a plus 3. And then I have the square root of, well, 1 plus 3 is 4. The square root of 4 is 2. So I get -1/2. So that's the slope of my tangent line, -1/2. How do I find the equation of the line? What point? So we know that the slope of the line is -1/2, and we just need a point that the line goes through to find the equation of the line. And what is in the problem, what point are we given that the line goes through? -1, 2, right? Because it's the tangent line at that point. That means it goes through that point. So our x0, y0 is negative 1, 2. That's the slope of the line. Let's call it m. And now we're ready for the equation. Y minus y0 equals m, negative 1/2 times parentheses x minus x0. That's x minus negative 1. And that's the equation of the tangent line. But we should write it as, I guess, it depends on how picky, if you're taking a calculus class, it depends on how picky, if there's a specific format that they're looking for. I mean, some instructors would be okay with this, but, there are parentheses, and you're not really saying what y is equal to. I mean, you're saying what y minus 2 is equal to, so I think it's just better to solve for y. So you get 2 plus, and then negative 1/2 x, and then minus 1/2. So then this is going to be 2 minus 1/2 is 3 over 2, plus negative 1/2 x. So I'm actually going to write it in the mx plus b form. Negative 1/2 x plus 3 over 2 equals y. Remember, that's the equation of the line. The equation of the line is actually an equation. So if it's just negative 1/2 x plus 3 over 2, that's not correct. It needs to be y equals negative 1/2 x plus 3 over 2. That will give you an equation of a line. Okay. So that's part A. Part B says, find the equation of the normal line to the graph of the function at the point negative 1, 2. Well, first of all, to find the equation of a normal line, you have to know what that even is. Do you know what that means, the normal line? It's the line that's perpendicular to the tangent line. It's the line that's perpendicular to the tangent line. And do you know when you have two lines? So, if your tangent line, what did we say the tangent line was? Negative 1/2 x plus 3 over 2. Okay, so that has, why am I scrolling? Okay, so tangent line has a slope of negative 1/2, right? Let's say there's your tangent line. Slope is negative 1/2. And then you have the perpendicular line. So that would be the normal line. And by the way, where do they intersect? They intersect at negative 1, 2. Right? Because we're finding the normal line to the graph at the point negative 1, 2. So if the tangent line has slope negative 1/2, and you have these two lines that are perpendicular, do you know what the slope of the normal line is going to be? When you have two lines and they're perpendicular, what's the relationship between their slopes? They're negative reciprocals of each other. In other words, when you multiply those two slopes, you're supposed to get negative 1. So based on that, what's the slope of the normal line? If I take the reciprocal of negative 1/2 and then multiply that by negative 1, what do I get? Well, the reciprocal of negative 1/2 is negative 2. And if I multiply that by negative 1, I get positive 2. So the normal line has slope 2. And using this, can you find the equation of the normal line? Yes, because it goes through the point negative 1, 2. So let's write that down. Since the tangent line has slope negative 1/2, the normal line has slope, so negative 1 over negative 1/2. And that's negative, negative 2, and that's positive 2. And since the normal line goes through negative 1, 2, so again we have x0, y0 is negative 1, 2. Can you finish the problem? The equation of the line is y minus 2 equals m. But this is the slope of the normal line. That's 2 times x minus x1, which is negative 1. And again, I'm going to solve for y, so I'm going to get y minus 2 equals 2 times x plus 1. Then y minus 2 equals 2x plus 2. Add 2 to both sides, y equals 2x plus 4. And that's the answer. That's the equation of the normal line. And then part C says, where does the normal line intersect the x-axis? Okay, so this is really like an algebra thing. Right? We have a line. See, C is not a calculus problem. It's really A and B where you're doing, I mean, really, A is where the calculus shows up because of the chain rule. And then part B is just, well, the normal line is perpendicular, and then you have to know the fact about the slopes. And then part C, where does this line intersect the x-axis? I mean, hopefully that's something you remember from algebra. If you have this equation, this line, y equals 2x plus 4, where does it intersect the x-axis? Well, the x-axis is given by what equation? What can you say about x or y when you're on the x-axis? The x-axis is this one, right? This is the x-axis. So that's when y is equal to 0. So you have this line 2x plus 4, y-intercept is 4, slope is 2, and you want to figure out where does it intersect the x-axis. So you set y equal to 0, and then you solve for x. So, okay, you can probably do this in your head. You get negative 2. So the answer is it intersects the x-axis at negative 2, 0. That's this point, negative 2 comma 0. And that's it for this example.